Picture a landscape far from Earth, where the horizon is a stretch of red dust under a sky dotted with unfamiliar constellations. Here lies a frontier unlike any before it, as humanity takes its first steps on the Martian surface. But as we touch down in this new world, a question looms: how will we sustain life in such a harsh and unforgiving environment? This is where technology becomes our greatest ally, with 3D printing standing out as a beacon of hope. Imagine constructing habitats from the very soil beneath our feet or crafting tools on demand, tailored to our needs. The potential to build, live, and thrive in space without the constant tether to Earth is not just a dream but a burgeoning reality. And this pursuit of sustainability extends beyond the stars, offering revolutionary insights for conserving resources and reducing waste on our home planet. Throughout this video, we will unravel these themes and confront the challenges that accompany life beyond Earth. We'll delve into how 3D printing is central to this cosmic puzzle, exploring its transformative potential in creating truly sustainable living environments in space colonies. So, how does 3D printing fit into this cosmic puzzle? Let's embark on this fascinating quest to find out. Now turning to the evolution of 3D printing technology, let's journey back to its origins. Initially conceived in the 1980s, 3D printing, or additive manufacturing, began as a method for creating prototypes quickly and efficiently. Early developments in stereolithography laid the groundwork for producing three-dimensional objects layer by layer, a revolutionary step away from traditional subtractive manufacturing methods. Through decades of research and development, this technology has transcended its humble beginnings, evolving into a versatile tool with applications ranging from healthcare to aerospace. As we enter the new millennium, 3D printing has not only matured but diversified, enabling the production of complex items with precision and minimal waste. This transformation from a nascent innovation to a cornerstone of modern manufacturing highlights how 3D printing has expanded its horizons. The notable advancement in materials, from basic plastics to sophisticated metals and ceramics, has unlocked new possibilities, allowing for durable and functional components that meet rigorous standards. As the capabilities of 3D printers have amplified, so too has their application in space exploration, a frontier that demands ingenuity and resourcefulness. Organizations like NASA and the European Space Agency have spearheaded efforts to incorporate 3D printing in their missions. A remarkable milestone was achieved when a 3D printer was successfully deployed on the International Space Station, enabling astronauts to print tools and parts on demand. This breakthrough not only saved valuable time, but also demonstrated the technology's potential to reduce reliance on Earth-bound supply chains. These pioneering efforts have set the stage for ambitious projects that aim to utilize 3D printing for constructing habitats on extraterrestrial surfaces using local materials. Such projects are essential as we envision sustainable living in space colonies. As the sun rises on the next chapter of this story, we will explore how harnessing local resources like lunar or Martian soil can further enhance the self-sufficiency of space colonies. This concept, known as localized resource utilization, promises to play a crucial role in overcoming the logistical challenges of sustaining life beyond our planet. With the next phase of the journey in sight, let's explore the concept of utilizing in-situ resources, a promising solution to the immense challenges of space colonization. Central to this approach is the idea of sourcing materials directly from extraterrestrial environments, thereby minimizing the need to transport bulky and expensive supplies from Earth. This not only reduces the logistical burden and cost, but also enhances the viability of long-term human presence in space. Imagine the surfaces of the Moon or Mars yielding raw materials for construction through 3D printing technology, a transformative shift in how we envision off-world living. Lunar regolith and Martian soil, often regarded as barren, hold the potential to become the building blocks of future habitats. With advanced 3D printing processes, these materials can be converted into essential components like building modules and structural supports. This paradigm shift is critical for the self-sufficiency of space colonies, enabling them to thrive independently from Earth. However, the path to fully realizing in-situ resource utilization is fraught with technological and engineering hurdles. For instance, understanding the properties of lunar and Martian raw materials and how they interact with 3D printing processes is crucial. Scientists and engineers are rigorously testing to determine the feasibility of using regolith as a reliable and robust construction medium. This involves developing specialized printers that can operate in the harsh conditions of space, handling materials that differ vastly from those used here on Earth. Another challenge lies in ensuring that the printed structures can withstand the extreme environments of space, including temperature fluctuations and radiation exposure. Innovative research and experiments are underway to create sustainable, durable materials that can endure these conditions. Moreover, strategies are being devised to overcome the constraints posed by the limited resources available on celestial bodies, ensuring that habitats can be both functional and economically viable. Utilizing local materials supports sustainable living by drastically reducing our reliance on Earth-based resources. By crafting essential structures on site, space colonies can achieve a level of self-sufficiency necessary for their long-term success. This approach not only lowers the carbon footprint associated with transporting materials, but also encourages a mindset of resourcefulness and innovation. In summary, leveraging in-situ resources through 3D printing marks a significant leap toward sustainable space colonization, paving the way for human settlement beyond our home planet. As we delve deeper into this methodology, we will discover how it intertwines with other aspects of sustainable living, such as building infrastructure and producing food, propelling us towards a future where space is not just a frontier but a home. Moving forward, let's delve into the fascinating process of building infrastructure with 3D printing, a cornerstone of crafting sustainable living environments in space. Imagine futuristic outposts, intricately designed yet robust, built not by human hands but through automated 3D printing processes. This technology allows for the creation of habitats that not only withstand the harsh conditions of space but also offer safe and comfortable living spaces for colonists. Architects and engineers are drawing inspiration from nature, creating structures that mimic the resilience and efficiency found in biological systems. For instance, designs inspired by beehives or honeycombs offer remarkable strength and energy efficiency, perfect for the volatile environments of space. Material selection is critical too. Instead of traditional steel or concrete, space habitats might utilize basalt fiber, a potentially abundant material derived from lunar or Martian rocks. This not only utilizes local resources but also provides excellent thermal stability and radiation shielding. Automation plays a pivotal role in this construction process. Autonomous 3D printers capable of operating day and night without human intervention are essential for building these habitats. These machines can adapt to the ever-changing conditions of space, ensuring the safety and integrity of the structures they create. The flexibility inherent in 3D printing technology allows for rapid adjustments in design, accommodating unexpected challenges or changes in requirements. This adaptability is vital in space, where conditions can shift dramatically. Real-world prototypes already demonstrate the potential of 3D printing in space construction. For example, NASA's ongoing research and partnerships with private companies focus on developing technologies to print structures on the Moon and Mars. Experiments like printing entire mock habitats here on Earth provide valuable insights into the capabilities and limitations of 3D printing in an extraterrestrial setting. This approach not only accelerates construction timelines, but also reduces the costs and risks associated with human-led building efforts in space. The ability to construct exactly what is needed when it is needed revolutionizes how we think about establishing and expanding human presence in space. Transitioning now, we'll explore how this incredible technology supports the daily sustainability of life in space, ensuring that habitats are not only built to last but also to nurture and sustain their inhabitants for generations to come. Now turning to sustainable food production, let's examine how 3D printing is poised to revolutionize how we create meals in space, using minimal resources to deliver both nutrition and flavor. In the unique environment of space, traditional farming is not feasible, and thus, innovation in food technology becomes crucial. Imagine meals crafted layer by layer, with precise control over texture and flavor, mirroring the delightful tastes and appearances we're accustomed to on Earth. This is where 3D food printing comes into play, enabling astronauts to enjoy a diverse menu that is both nourishing and tailored to individual dietary needs. One of the remarkable advancements in this field is the use of alternative protein sources. For instance, algae, insects, and lab-grown meats can be transformed into delicious, protein-rich dishes through 3D printing. These sources not only bypass the constraints of traditional agriculture, but also offer a sustainable method to meet nutritional requirements in space. Furthermore, the ability to recycle organic material to create new food items is an exciting frontier. This closed-loop system ensures minimal waste and maximum efficiency, aligning perfectly with the principles of sustainability critical for long-term space missions. However, ensuring food safety and nutritional adequacy presents its own set of challenges. In space, the lack of gravity affects how food is prepared and consumed, requiring careful consideration in designing meals that are safe and palatable. Fortunately, 3D printing technology is continuously adapting to these conditions. Innovations in food encapsulation and preservation techniques are helping to maintain the quality and safety of printed meals, alongside advancements in nutritionally optimized materials that ensure astronauts receive all necessary vitamins and nutrients. As the technology advances, it holds the potential to provide personalized nutrition. 3D printers could use biometric data to create customized meals that address individual health needs and preferences, thereby enhancing the overall well-being of space colonists. This is not just a futuristic dream but an emerging reality, as ongoing research and pilot projects work to refine these systems. With the next phase of the journey in sight, we see that 3D printing is not only transforming how we nourish ourselves in space, but also contributing significantly to waste management and recycling efforts. By creatively converting byproducts and waste into usable materials, this technology supports a sustainable ecosystem where every resource is optimized, setting the stage for the next discussion on the essential role of 3D printing in managing waste and recycling in space colonies. As the next challenge unfolds, we delve into the realm of recycling and waste management, where 3D printing plays a pivotal role in establishing a closed-loop system for space colonies. In the unique environment of a space habitat, waste is not merely a byproduct to be discarded but a valuable resource to be repurposed. Utilizing 3D printing technology, waste products can be transformed into essential items or materials necessary for daily life in space. This innovative approach significantly reduces the reliance on fresh supplies from Earth and maximizes the utility of every resource, aligning perfectly with the principles of sustainability that are vital for long-term space missions. A fascinating aspect of 3D printing in recycling is its ability to convert a wide variety of waste materials. Organic waste, plastics, and even metal scraps can be processed and repurposed into new products or building materials. For instance, plastic containers and packaging could be melted down and printed into new tools or spare parts, supporting the ongoing needs of the space colony. This adaptability not only promotes efficient resource management, but also fosters the development of a self-sustaining ecosystem where material reuse is the norm. However, maintaining an effective recycling system in the harsh environment of space presents unique challenges. The degradation of materials over time poses a significant hurdle, as does ensuring that the recycled products meet the same safety and quality standards as those manufactured on Earth. Research is actively exploring new methods and materials to enhance the durability and functionality of recycled goods, with promising developments in nanotechnology and material sciences showing the potential to mitigate these concerns. Additionally, the need to constantly innovate and adapt recycling techniques is crucial, as the space community seeks to improve the efficiency and effectiveness of these systems. These advancements not only hold promise for space exploration, but also offer valuable insights that could revolutionize recycling processes on Earth. By continuously repurposing waste, 3D printing helps create a sustainable cycle, reducing the dependency on external supplies and supporting the overall mission of creating a self-reliant space society. With this understanding of how 3D printing transforms waste management, we can appreciate its broader implications. As we turn our attention to the next critical role of 3D printing, we explore its transformative impact on healthcare, offering unprecedented possibilities for medical applications that enhance the well-being of space inhabitants. Now turning to a crucial aspect of sustaining life far beyond our home planet, we venture into the transformative realm of healthcare and medical applications enabled by 3D printing technology. In space, where the nearest hospital is millions of miles away, having the ability to print medical tools and equipment on demand is not just a convenience, it's a necessity. Imagine the potential to print surgical instruments, custom-fitted prosthetics, and even complex biological tissues when emergencies arise. This capability could redefine emergency medical response in space colonies, offering a lifeline when traditional medical supplies may not be readily available. The challenges of maintaining health in space are manifold. Astronauts are exposed to unique physical stresses and health risks that do not occur on Earth, ranging from radiation to muscle atrophy and bone density loss, all of which demand innovative solutions. Here, personalized medicine through 3D printing emerges as a beacon of hope. With this technology, medications can be tailored to the precise needs of each individual, optimizing efficacy and minimizing side effects. This approach could significantly enhance the overall wellness of space inhabitants, providing a tailored healthcare experience that is responsive to the unique pressures of space life. Bioprinting, a rapidly growing field of research, holds promise that extends even further. Scientists are exploring the potential to print living tissues, with ongoing experiments showing encouraging progress in creating viable skin grafts and perhaps one day more complex organs. These advancements could pave the way for revolutionary medical treatments, not only in space but also on Earth, where organ shortages and complex transplant logistics pose significant challenges. The implications for space medicine are profound, offering a future where severe injuries can be treated with printed tissues and organs, contributing to a robust healthcare system within space colonies. With the benefits of 3D printing in healthcare clear, the technology's role in supporting daily operations in space becomes even more evident. Transitioning to our next focus, we will explore how 3D printing reinforces the sustainability and functionality of space missions by aiding in the repair and maintenance of equipment. By producing essential parts on site, 3D printing reduces reliance on earthly resources, ensuring that missions remain viable and equipment stays operational in the challenging environment of space. As the next challenge unfolds, we explore the pivotal role of 3D printing in equipment maintenance and repairs, a lifeline for space missions operating far from Earth. In the vast expanse of space, where waiting for a delivery from Earth could take months, the ability to produce replacement parts and tools on site can mean the difference between success and failure. This capability minimizes downtime and ensures that critical operations continue smoothly without unnecessary delays. Imagine a scenario where an essential piece of machinery fails. Instead of halting the mission while waiting for a replacement, astronauts can swiftly print the needed part, allowing them to resume their work almost instantaneously. This not only boosts operational efficiency, but also enhances the mission's flexibility to adapt to unforeseen challenges. The significance of 3D printing in sustaining operations goes beyond mere convenience. It is a cornerstone of the mission's success and longevity. In space, where every kilogram of cargo is calculated with precision, relying on Earth for spare parts is not only costly but impractical. 3D printing addresses this issue by enabling astronauts to utilize digital blueprints and local resources to fabricate parts as needed. This self-sufficiency is crucial in the remote and resource-scarce environments of space, where the unexpected is a constant companion. It allows missions to extend their duration and scope, pushing the boundaries of exploration without being tethered to Earth for supplies. There are already remarkable examples of successfully printed equipment on space missions. One such instance is the production of a ratchet wrench on the International Space Station using a digital design sent from Earth. This achievement marked a significant step in proving the feasibility of in-situ manufacturing. The wrench was created using a process known as fused deposition modeling, a technique that has since been refined and expanded upon. Another successful endeavor was the printing of a housing for a radiation detector, showcasing the potential to create complex components vital for scientific research and safety in space environments. With these advancements, 3D printing not only aids in immediate repairs but also opens up possibilities for creating entire infrastructures using locally sourced materials. This technology supports diverse human needs beyond basic survival, offering a vision of space colonies that are self-reliant and capable of thriving independently. As we delve deeper into the potential of 3D printing, it becomes clear that its applications in space extend far beyond maintenance and repairs. It stands to revolutionize every aspect of life in space colonies, from constructing habitats to producing tools and machines tailored to the unique challenges of extraterrestrial living. Looking ahead, we will consider how 3D printing can further support sustainable living by fulfilling diverse human needs, transcending mere survival to enriching the quality of life in space colonies. Now turning to the cultural and social aspects, 3D printing is poised to play a transformative role in enriching the lives of space colonists. Beyond the critical applications in construction and repairs, this technology can significantly enhance the quality of life by fostering a sense of community and belonging. When venturing far from Earth, maintaining cultural identity and social connections becomes paramount for mental well-being and psychological resilience. Imagine, for instance, the ability for colonists to create art and personal items that resonate with their cultural heritage, or to produce artifacts that symbolize their traditions. These tangible objects can serve as comforting reminders of home, helping to alleviate feelings of isolation and homesickness that might arise in the harsh landscapes of outer space. Moreover, 3D printing facilitates the customization of these cultural artifacts, allowing individuals to express their unique identities and personalities. Personalization can lead to a more vibrant community where diversity is celebrated and each person feels a deeper connection to their surroundings. This sense of identity and belonging is crucial for the emotional health of space colonists, contributing to overall morale and cohesion among crew members. Additionally, 3D printing opens up creative avenues for collaboration and shared experiences, which are vital for nurturing social bonds. Colonists can engage in communal projects, such as designing shared spaces or creating artworks that reflect their collective journey. Working together on these projects not only strengthens community ties but also stimulates creativity and innovation, as individuals bring different perspectives and skills to the table. In terms of practical applications, there have already been fascinating examples of 3D printing being used in creative ways during space missions. For instance, astronauts have experimented with printing musical instruments, which provide both entertainment and stress relief. The ability to produce personalized items like family photos or small tokens can further enhance the quality of life by allowing colonists to keep cherished memories close at hand. As we look to the future, the potential of 3D printing to support cultural and social well-being in space colonies is boundless. This technology is likely to evolve, incorporating advanced materials and more sophisticated design capabilities. Such advancements could lead to even more intricate and meaningful creations, pushing the boundaries of what is possible in expressing human culture and connections. Moving forward, the integration of 3D printing into the cultural fabric of space colonies represents a promising stride towards making these habitats more than just places of survival. They become places where human spirit thrives, where creativity flows freely, and where the essence of what makes us human is preserved. This cultural enrichment is key to building sustainable communities in space, where individuals not only survive but truly live and flourish. With the next phase of innovation on the horizon, we anticipate that 3D printing will continue to redefine what it means to inhabit new worlds. As the next phase of the journey in sight, we delve into the future innovations and trends that could shape the role of 3D printing in space colonies. Envision a future where 3D printing not only assists in basic survival tasks, but also evolves into a cornerstone technology that significantly enhances living conditions in extraterrestrial environments. One of the major advancements on the horizon is the development of advanced materials specifically tailored for space applications. These materials could provide enhanced durability and adaptability, crucial for constructing habitats that can withstand the extreme conditions of outer space while using minimal resources. Imagine materials that adapt to temperature fluctuations or have properties that allow them to repair themselves, reducing the need for maintenance and extending the lifespan of structures. Moreover, the integration of increased automation and artificial intelligence into the 3D printing process promises to revolutionize how we approach construction and manufacturing in space. Automated systems could manage complex tasks, from creating intricate designs to performing maintenance operations efficiently and with minimal human intervention. Artificial intelligence could optimize production processes by making real-time adjustments, ensuring precision and resourcefulness. This not only accelerates the development of infrastructure, but also frees up colonists to focus on other critical activities for sustaining life and exploring their new environment. The implications of these innovations extend beyond the boundaries of space exploration. On Earth, such advancements could lead to more sustainable production methods, reducing waste and conserving resources by allowing for localized manufacturing. This could drive progress in industries like construction, healthcare, and even food production, where precise and adaptable manufacturing processes could lead to groundbreaking efficiencies and reduced ecological footprints. As these trends unfold, they also offer a unique opportunity to inspire international collaboration and progress. Space exploration has always been a realm that transcends borders, and the shared challenges of living sustainably in space could foster global cooperation in developing these transformative technologies. Countries and organizations working together to push the boundaries of 3D printing technology can pave the way for a more united approach to solving universal sustainability challenges, both in space and on Earth. In this exciting frontier, 3D printing stands not just as a tool for survival, but as an engine for innovation that holds the potential to redefine how we live, create, and collaborate. Now turning to the broader implications for Earth and global society, The technological advancements emerging from 3D printing in space are not confined to the realms of science fiction but hold tangible benefits for our planet. The innovations necessitated by space colonization offer transformative solutions to pressing sustainability challenges we face right here on Earth. At the forefront is cross-industry innovation. The breakthroughs in constructing habitats with 3D printing technologies in space could revolutionize housing and infrastructure on Earth. Imagine entire buildings printed from locally sourced materials, drastically reducing carbon footprints and construction waste. Such advances could democratize access to sustainable housing, making it affordable and environmentally friendly. This paradigm shift extends to environmental conservation and resource management. By utilizing 3D printing to recycle existing materials, we can significantly reduce the strain on natural resources. This method not only conserves raw materials but also curbs pollution by cutting down on waste. The insights gained from managing limited resources in space could lead to a more circular economy on Earth, where products are designed and manufactured with their entire life cycle in mind. Beyond the environmental and industrial realms, fostering international collaboration and technological advancement stands as a profound societal benefit. Space exploration has always been a unifying endeavor, inspiring cooperation among nations. As we develop these advanced 3D printing technologies, there is immense potential for global collaboration, bringing together the brightest minds across nations to innovate for the common good. Such collaboration can pave the way for shared technological progress and mutual understanding, critical in addressing global challenges like climate change and sustainable development. Furthermore, 3D printing's role in healthcare developed for space environments might revolutionize medical treatments on Earth. The ability to produce medical supplies and even biological tissues on demand could enhance healthcare accessibility and reduce medical waste. This could be particularly transformative in remote or underserved regions, bridging the gap between need and availability. Finally, the lessons learned from creating sustainable life in space can inspire educational and cultural exchanges, promoting a global dialogue on sustainability and innovation. As humanity reaches for the stars, these developments serve as a reminder of our collective ingenuity and the potential for technology to improve life on our home planet. Transitioning to concluding thoughts, we reflect on the transformative journey of 3D printing in enabling sustainable living, both in space colonies and on Earth. This technology, at the intersection of innovation and necessity, holds the power to redefine our approach to living sustainably, urging us to dream big and work together for a brighter future. As the sun rises on the next chapter of human innovation, we reflect on the transformative journey we've explored with 3D printing technology in space. From the outset, it was clear that this technology could be the linchpin in enabling sustainable living within space colonies. We've seen how 3D printing addresses a myriad of challenges, from building habitats using local materials to creating essential medical supplies on demand. These advancements not only promise a viable future on other planets but also cast a beacon of hope back here on Earth. The broader implications for humanity are profound. As we look to the stars, we are reminded of our potential to transcend boundaries and reimagine sustainability. The insights and technological innovations birthed from space endeavors could fundamentally alter how we approach environmental conservation, resource management, and even healthcare on our home planet. It's a testament to our collective ingenuity and resilience qualities that have always driven human progress. As we dream of future habitation beyond Earth, we are prompted to consider how these advancements could inspire new ways of thinking and living sustainably right here. Imagine a world where space-inspired solutions lead to cities that coexist harmoniously with nature, where pollution is history and where resource scarcity is a challenge of the past. It's this vision of a sustainable future, both on Earth and in the cosmos, that beckons us to continue pushing the limits of what's possible. let us not forget the inspiring spirit of exploration that drives these advancements. As we explore the unknown, we are inherently choosing to innovate and collaborate, harnessing the potential of technology to create a brighter future. A quote that beautifully encapsulates this spirit is from Carl Sagan. "Somewhere, something incredible is waiting to be known." As we venture further into space with tools like 3D printing, we move closer to uncovering those incredible possibilities. Now, I invite you to share your thoughts and dreams for the future. How do you envision the role of technology like 3D printing in shaping our world? Please engage with us and one another in the comments below. If you found this exploration insightful, I encourage you to subscribe to our channel for more fascinating insights into the world of futuristic technologies. Together, let's journey toward a sustainable and inspiring future.